Tell me the answer of this question. The distance covered by particle undergoing SHM in one time period is, okay, amplitude is A, so 0, A, 2A, 4A. What would be the answer? This is one of the simplest question. Option A. Question is distance covered by a particle undergoing SHM. Answer is 4A. Okay, see how. So see, let's suppose this block performs SHM. Okay, so it starts from mean position. It goes from this mean position to plus A, so 0 to plus A, then it comes back to 0, then it goes to this position minus A, now again it comes back to 0. Okay, so it is A plus A plus A plus A, 4A, right? So answer is 4A. Next question, the displacement of a particle along x-axis is given by x equals to a sine square omega t. The motion of particle corresponds to. So tell me simple harmonic motion of frequency omega divided by pi, simple harmonic motion of frequency 3 omega upon 2 pi, non-simple harmonic motion or simple harmonic motion of frequency omega upon 2 pi. So see this question, here x is equal to a multiplied by sine square of omega t, right? So we have seen in case of simple harmonic motion, x is given by what? A multiplied by sine of omega t. So when you see it, okay, it seems like this is not a simple harmonic motion. If you just see this formula and compare it with this formula, looks like it's not a simple harmonic motion, but it is. How come? So sine square omega t, it can be written as 1 minus, you know this formula, 1 minus cos 2 theta equals to 2 sine square theta by 2, sorry, 2 sine square theta, the half angle formula. Okay, so therefore this can be written as, this thing can be written as sine square omega t can be written as what? 1 minus 2 times cos of 2 omega t, okay, sorry, what I am doing, 1 minus cos of 2 omega t divided by 2, and multiplied by this a. So you have a by 2 multiplied by, sorry, minus a by 2 cos of 2 omega t. Now, is it simple harmonic motion or not? So when t is equal to 0, okay, when t is 0, what do you get? X is also 0, I guess. Okay, t is 0, cos 0 is 1. Yeah, then a by 2 minus a by 2 is 0. Yeah, so this is simple harmonic motion about x equal to 0 only, right? But frequency, it is not omega. Angular frequency is not omega, it is 2 times omega. Okay, angular frequency is 2 times omega. That means the frequency will be what? Frequency will be, see, angular frequency is omega dash, is 2 times of omega. So frequency omega dash can be written as 2 pi times f. It is 2 omega, and therefore f is equal to what? 2 omega divided by 2 pi. So 2 and 2 gets cancelled, omega upon pi. So option A is the answer. It is simple harmonic motion of frequency omega upon pi. Particle executes simple harmonic oscillation with an amplitude A. The period of oscillation is T. The minimum time taken by the particle to travel half of the amplitude from equilibrium position is. Okay. So actually it will take fixed amount of time, not the minimum time, right? Every time it will take same amount of time. Okay. So particle is starting from mean position. So which equation do we have to use? X equals to A sine of omega t, and omega can be written as 2 pi by t. So when you solve this in exam, any question based upon oscillations, so you should directly use this formula. X is equal to A sine of, in place of omega, put 2 pi upon t. Okay, so 2 pi upon t times t. And what's given? The distance traveled is, okay, the minimum time taken by particle to travel half the amplitude. So distance is equal to half of the amplitude. X is equal to A by 2. Okay, so X is A by 2. So A and A gets cancelled. We get sine of this thing 2 pi upon t times t is equal to half. Okay, A and A gets cancelled. That means this thing is equal to what? 30 degrees, right? Sine of 30 degrees is half. Okay, and how do we write 30 in terms of pi? Okay, so it is pi by, pi radians is 180 degrees. Okay, therefore we want 30 degrees, so it is pi by 6, right? 180 divided by 6 is 30. So this is, okay, sine of this angle is half. That means this angle 2 pi upon t times t is 30 degrees. That is pi by 6. So this thing gets cancelled, pi and pi gets cancelled. Sorry. So you get t equals to what? A capital T on this side and 2 on this side. So it is t by 6 times 2, t by 12. In question, they have mentioned this. Okay, t is equal to capital T by 12. This is the answer. See, your question is, they are not mentioning mean position. They are saying it's equilibrium position. Equilibrium means mean. Okay, all right. So why is it called as equilibrium position? Because at mean position, force is equal to 0. So force is 0 means it is equilibrium. One thing, in last test, Preeti scored 141. Okay, so I want somebody to overtake her in next test. So this Sunday will not have a test, because, not because we cannot have. I have some work. Okay, so because of that, I will not be able to create test paper. Anyways, So let's see this next question. The circular motion of a particle with constant speed is periodic but not simple harmonic, simple harmonic but not periodic, this is not periodic and simple harmonic, neither periodic nor simple harmonic. Which one? It is periodic but not simple harmonic. Option A. Right. So why is there so much of confusion? Circular motion is not to and fro motion, right? Okay. There is always some force directed towards some position. Okay, towards the center of circle. But it is not to and fro motion. Okay. So it is not simple harmonic motion. All right. Next question. A simple harmonic oscillator has an amplitude A and time period capital T. The time required by it to travel from x equal to A to x equal to A by 2 is. So see, it is going from x equal to A. That means we have to use which equation? X is equal to A multiplied by cos of omega t. Cos of 2 pi, we'll write it afterwards, omega t. Okay, because particle is starting from extreme. Okay, then uh, we want to find out time required by it to travel from x equal to A to A by 2. Okay, so let's put x equal to A by 2. So it is A by 2 equals to A multiplied by cos of omega t. Okay, so A gets cancelled. Cos omega t is half. That means omega t is 60 degrees. Okay, so omega t, what's happening? Oh, sorry. Omega t is 60 degrees. Okay, omega t is 60 degrees means how much in radians? Pi by 3. So omega is 2 pi upon t. Okay, so pi and pi gets cancelled. Pi and pi gets cancelled. So t equals to t by 6. Right. So option A is the answer. This thing we haven't seen. Okay. Average velocity of a particle executing SHM in one complete vibration is, tell me, 0, A omega upon 2, A omega square upon 2. Option A. Very good. It's 0. Okay. So in one complete oscillation, particle starts from some position, comes back to the same position. Average velocity is 0. Right. Okay. A particle executes linear simple harmonic motion with an amplitude of 3 centimeters. When the particle is at 2 centimeter from mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period in seconds is. So, okay. So its amplitude is given, it is 3 centimeters. And when particle is at x equals to 2 centimeters from the mean position, the magnitude of its velocity is equal to acceleration. Then its time period in seconds is. Okay. So magnitude of velocity. Velocity is given by omega square root of a square minus x square. We just want magnitude. Okay. This is equal to, it's equal to magnitude of acceleration. So it is omega square x. Right. Okay. Then this omega and omega. will get cancelled out. This thing gets cancelled out. Then we can take square on both sides. So we get a square minus x square equals to omega square x square. Okay. And then you can substitute the values because you want to find out what? You want to find out time period. Okay. So let's substitute the values. A is equal to 3. So this is 9 minus 4 is equal to omega square multiplied by 4. So 4 times omega square. So 5 equals to 4 times omega square. Therefore, 5 by 4 is omega square. Omega square equals to 5 by 4. And you want time. So this is 2 pi upon t square. Okay. So let's take square root. Omega equals to, it is square root of this thing. So it is square root of 5 is square root of 5 divided by 2. Okay. Square root of 4. So it is 2 pi divided by t is this thing, square root of 5 by 2. Now let's move this t on other side, okay, and other things on left hand side. So we get t equals to what? T equals to, it will be 4 pi divided by root 5. Okay, so this option B is the answer, right? Okay, so this is again a simple question. All right, let's discuss this question. A particle is executing a simple harmonic motion. Its maximum acceleration is alpha and maximum velocity is beta. Then its time period of vibration will be. Okay. So maximum acceleration A max is alpha. How much is maximum acceleration? It will be omega square A, right? And maximum velocity is beta. That means beta is equal to A multiplied by omega. Okay, because velocity is omega square root of a square minus x square. So if you put x equal to 0, then you get maximum velocity, right? So it is a times omega. Okay, so when x is equal to 0. Okay, so you want to find out time period. So again, this is a simple question. Divide this with this. Okay, so omega and omega gets cancelled. A and A gets cancelled. You get omega equals to alpha upon beta. That means 2 pi upon t. 2 pi divided by capital T is alpha upon beta. That means capital T is equal to what? It is 2 pi times beta upon alpha. Okay, option B. This is the answer, right? A particle is executing SHM along a straight line. Its velocities at distances x1 and x2 from the mean position are v1 and v2 respectively. Its time period is. Particle is executing SHM along a straight line. Its velocities at distances x1 and x2 from mean position are v1 and v2 respectively. Its time period is. This is the question. So what should we do? We can write down expressions for velocities. What will be v1? It is omega multiplied by square root of, is their amplitude same? Yes, no? Yeah, it's same particle only. So it's omega multiplied by a square minus x1 square. Okay, v2 is omega multiplied by a square minus x2 square. then what can we do? So we can square them. Okay, so squaring them will get v1 square multiplied by v2 square equals to omega square a square, omega square a square minus x1 square, not x1 square. There will be omega square in multiplication, and omega square a square minus omega square x2 square. Okay, now we want time period, and see there is no a in any of these expressions. We can get rid of it. We just have to subtract these equations. Okay, subtracting, what do we get? v1 square minus v2 square equals to, so here this thing and this thing will get cancelled out. Then it is uh, this will become minus of minus, so that's positive, minus minus plus. Okay, then omega square x2 square minus omega square x1 square, or we can take omega square common. We want to find out the time period. This v1 square minus v2 square equals to omega square multiplied by x2 square minus x1 square. Okay, so let's take this on other side, or let's keep it. So it is, what is omega? Yeah, let's take this on other side. So what do we get? Omega square equals to v1 square minus v2 square upon x2 square minus x1 square, right? And then we can take square root of this. We can take square root of this. So we get omega. And what is omega? It is 2 pi upon t. So 2 pi upon t is this thing. Okay. So 2 pi upon t is this thing. So let's take reciprocal of it. So we get t upon 2 pi equals to x2 square minus x1 square divided by v1 square minus v2 square. And now we can move that 2 pi on other side because we want period. Sorry. Okay. So this is the answer. So option D is the answer. The radius of a circle, the period of revolution, initial position, and sense of revolution are indicated in figure. Y projection of the radius vector of rotating particle P is. See this particle, it is at this position at t equals to 0. It's given. It is moving in clockwise sense. Okay, it's moving in clockwise sense. Okay, so how to think about it? See, after some time t, what will happen? It will go somewhere. Let's suppose it goes here. Okay, it's moving like this in in clockwise sense. So this much angle will be omega t. What will be omega? Omega is equal to 2 pi upon capital T. So omega t we want, it is 2 pi upon t, which is 2 pi upon, it's 4 seconds, 2 pi by 4 multiplied by t, or you can say it's pi by 2 times t. Okay, now it's clear actually. It's option A, right? Very good. Okay, because amplitude will be equal to what? Radius of circle, which is equal to 3 meters. 3 meters. Okay, so because it's moving like this angle is omega t. So if you draw a perpendicular from here, you get y projection. Okay, so that will be r multiplied by cos of omega t, right? Because it is through this angle. cos of omega t. Okay, so cos is there in this one, this one, this one, but uh, the phase is right in this one only. Okay, and that's why it's option A. Let's see next question. This you have to tell me. This is um, fairly recent, NEET 2020. Phase difference between the displacement and acceleration of a particle in a simple harmonic motion is pi, 3 pi by 2, 0. Okay. So Preeti told, is it correct? We just saw this, right? Phase difference between displacement and velocity is pi by 2. Velocity in acceleration is pi by 2. So displacement and acceleration, it is pi. Next question. The oscillation of a body on a smooth horizontal surface is represented by equation x is equal to a cos of omega t, where x is the displacement at time t and omega is frequency of oscillation. Which one of the following graphs shows correctly the variation of a with t? Acceleration with t. Tell me. See, x is a cos of omega t. So what will be a? It is a omega square minus of a omega square cos of omega t. So at t equals to 0, okay, this thing will be 1. So a is minus a omega square. It starts from negative value. Right? Yeah, it's option C. The particle of mass m oscillates along x-axis according to the equation x equals to a sine omega t. The nature of the graph between the momentum and displacement. We want the graph between momentum and displacement. That is, on y-axis we'll plot momentum, on x-axis we'll plot displacement. Okay, so x is a sine omega t, right? What will be velocity? It is equal to a omega multiplied by cos of omega t. Okay, and you want momentum. Momentum is mass into velocity, so it is ma omega cos of omega t. Okay, so then now if this was a only, that is if m and omega is equal to 1 and 1, then it could be a circle, right? Okay, this is, we are going to plot this on y-axis. Okay, so see, if you square and add x and y, what do you get? X square plus y square is equal to, okay, a square sine square omega t plus m square a square omega square cos square omega t. So if m and omega is equal to 1, you can take a square common, okay, then it will be sine square omega t multiplied by, sorry, plus cos square omega t, that's 1. So if m square and omega square, or m and omega is 1, then it would be a circle, because this is equation of a circle. Okay, but right now it's not the case. So what will be the answer? X square plus y square, okay, is this thing. Now see, if I divide y square, if I divide y square by m square omega square, okay, m square omega square, and then if I add them, so x square plus y square upon m square omega square. What do I get? I will get a square, it is sine square omega t plus a square cos square omega t, right? So what I have done is, now I am not adding x square and y square, I am adding x square and y square upon m square omega square. I will explain. Okay, why? So this thing, if you add, what do you get? You will get a square on right hand side. Now can you tell me, this is an equation of something? If you take that a square also on left hand side, okay, what do you get? X square upon a square plus y square upon a square m square omega square is equal to 1. So this is an equation of ellipse. Okay, equation of ellipse, it's x square upon, right, okay, x square by a square plus y square by b square is equal to 1. Or you can say x square upon a, sum a plus y square upon b is equal to 1. Okay, this is an equation of ellipse, right? So the answer is ellipse. Okay, now let's see how does that ellipse look like. Okay, so at okay, on x-axis we are going to plot a sine omega t. So at t equals to 0, at x equal to 0, that means at t equals to 0, what will be the value of this one? Okay, when x is 0, it is either plus a omega, sorry, plus ma omega or minus ma omega. Okay, what will this mean? Where at mean position, particle can be moving like this or like this. Okay, the magnitude of velocity will be same, right? So when x is 0, the momentum is ma omega or minus ma omega. Then when x is at the extreme position, okay, so when x is plus or minus a, then what will happen? So at that position, at the extreme position, we know the velocity is 0. So at plus a and minus a, the momentum will be 0, right? So ellipse will look like this. So it will look like this. So now it depends on values of m and omega. Okay, if m and omega is equal to 1 and 1, then what will happen? So this thing becomes a and this thing becomes minus a. So then it will be a circle. If m and omega, m times omega is less than 1, then you will see ellipse like this, which is, okay, elongated on x-axis, right? Because then this value will be smaller than this value. Okay, this length will be smaller than this length. And if m multiplied by omega is greater than 1, then this length will be more, right? Then you will see ellipse like this. Okay, ellipse like this. Is it clear? So let's see next question. Two simple harmonic motions of angular frequency 100 and 1000 radians per second have the same displacement amplitude. The ratio of their maximum acceleration is. So this is very simple. Okay, amplitude is same, but the angular frequency is, for first one it's 100, for second one it's 1000. Sorry. So what's the answer? Maximum acceleration. So a1 max divided by a2 max. We can say it is omega 1 square a divided by omega 2 square a. A is same, so this thing will get cancelled. Okay, so it is 100 divided by 1000 square. What's that? 1 upon 100, right? Option D. A coin performs simple harmonic oscillation of period t, and the equation of motion is given by x, x equals to a sine of omega t plus pi by 6. After the elapse of what fraction of time period, the velocity of the point will be equal to half of its maximum velocity. This is a simple question. We have solved similar question yesterday. Okay. Okay, let's solve this question and stop. Okay. So x is equal to, we have x equals to a sine of omega t plus pi by 6. So velocity will be what? Derivative of that, that is a omega multiplied by cos of omega t plus pi by 6. Okay. And we want the time at which the velocity becomes half of the maximum value. So maximum value is a omega. So velocity is half of that. Okay. So a omega and a omega gets cancelled. So we get half equals to cos of this thing, omega t plus pi by 6. So how much should be this angle? So cos of which angle is half? 60 degrees, right? 60 means pi by 3. Okay, so omega t plus pi by 6 is equal to pi by 3. That means omega t, what is omega t? 2 pi small t upon capital T is equal to pi by 3 minus pi by 6. That's pi by 6. Okay, so pi and pi gets cancelled out. So what do we get? T equals to, it is capital T divided by 12. Okay, option B is the answer. So let's see this problem. The phase difference between the instantaneous velocity and acceleration of a particle executing simple harmonic motion is at pi, 0.707 pi, 0, 0.5 pi. So the phase difference between velocity and acceleration. We saw similar kind of question yesterday, right? So what's the answer? Option D, 0.5 pi. Right. Okay. Phase difference between velocity and acceleration is pi by 2. Let's see this next question. A particle executing simple harmonic motion of amplitude 5 centimeter has maximum speed of 31.4 centimeters per second. The frequency of oscillations is. So this is very simple question, right? This is one of the simplest question. Okay, maximum speed is given, V max, it's equal to A times omega. Okay, and V max is 31.4 centimeters per second. A is equal to 5 centimeters. So from this we can find out omega, right? And omega can be written as 2 pi f, because we want frequency. Okay, so if we divide 31.4 by pi, we'll get 10, right? So then, so 10 is equal to 10f. That means f is equal to 1 hertz. Next question. Which one of the following statements is true for the speed v and the acceleration a of a particle executing simple harmonic motion? Option A, when v is maximum, a is maximum. Option B, value of sorry value of a is 0, whatever may be the value of v, when v is 0, I'm sorry. When V is maximum, A is maximum. That's first option. Value of A is 0, whatever may be the value of V. Then when V is 0, A is 0. When V is maximum, A is 0. Tell me which one is correct? See, there is V maximum at the mean position, right? V is maximum at mean position. And what is the value of A there? So acceleration is equal to 0 there, right? Yes, no? Okay, so it's option D. Okay, this was very simple. Next question. If a simple harmonic oscillator has got displacement of 0.02 meters and acceleration equal to 2 meters per second square at any time, the angular frequency of the oscillator is equal to. Again, this is very simple question. Displacement is given, it's 0.02 and acceleration is 2. So we know the relation between displacement and acceleration is what? A is equal to, so if we just care about the magnitude, then A is equal to omega square x, right? So we want angular frequency only, that means we want omega only. So omega square is A upon x, that is 2 divided by 0.02, that's 100. So omega is equal to 10 radians per second. Option A. A body is executing simple harmonic motion. When the displacement from mean position is 4 centimeter and 5 centimeter, the corresponding velocities of the body is 10 centimeters per second and 8 centimeters per second. Then the time period of the body is, okay. So we had solved similar kind of problem yesterday, okay, but there this thing was not given. I mean the values were not given. So V at V1 and V2 at positions x1 and x2, the speeds are V1 and V2. This thing was given, right? So here we can use this formula. V is equal to omega square root of a square minus, we can use this formula. V equals to omega square root of a square minus x square. So when x is 4, V is 10. So from that we get one equation, 10 equals to omega square root of a square minus, okay, 4 square. And then using the other information, when x is 5, v is 8, right? So 8 is equal to omega square root of a square minus 5 square. We get these two equations. Okay, so we can divide these two, cancel out omega, find out a, then substitute a to find out omega. Okay, so let's do that. So dividing, this thing gets cancelled. So we get 10 by 8 or 5 by 4, and squaring that we get 25 divided by 16 equals to a square minus 4 square is 16 upon a square minus. So from this we can find out a, right? So 25a square minus, so if I multiply this with this, it's 25a square minus 6 to 5 equals to 16a square minus what, 16 square, or from this we get, if we take 16a square on left hand side, okay, and 6 to 5 on right hand side, so it is 25a square minus 16a square is 9a square. So 9a square equals to 6 to 5 minus how much is 16 square? 256, right? 369. This is 9a square. So from that we get a square. So it will be 41, right? Okay. And we'll substitute a square. Right. So we'll substitute a square in this equation, okay, or this equation. So what do we get? A square is 41. 41 minus this 4 square is 16. Okay, so 10 is equal to omega multiplied by square root of a square minus 16, right? So a square is 41 minus 16 is how much? So it is 25. Okay, so we get 10 equals to omega times square root of 25, that is 5. Okay, so 5 omega equals to 10, that means omega equals to what? 2. Okay, so we got omega equals to 2, right? So 2 pi upon t is equal to 2, that means 2 pi upon t. So I will write it here. 2 pi divided by t is equal to 2, that means t is equal to t equals to 2 pi divided by 2. Okay, so option C is the answer, right? The displacement of a particle executing simple harmonic motion is given by y equals to a naught plus a sine omega t plus b cos omega t. Then the amplitude of its oscillation is given by. So this is simple. Tell me, I is equal to a naught plus a sine omega t plus b cos omega t. So here we have two SHMs, right? And yesterday we learned how to add two SHMs. Okay, option C, right? Okay, so amplitude is given by R is equal to a1 square square root of a1 square plus a2 square plus 2 times a1 a2 multiplied by cos of the phase difference between the two. Okay, so that is square root of a square plus b square plus 2 times a1 a2, that is a multiplied by b multiplied by cos of phase difference between these two. Phase difference between these two is pi by 2, right? It's pi by 2 and cos of pi by 2 is 0. Okay, so phase difference between sine and cos is pi by 2. Okay, so then this thing is 0, so answer is square root of a square plus b square, option C. All right, let us see next question. Out of the following functions representing motion of particle, which represents SHM? Tell me. First is SHM, yes or no? It is, right? This combination of two SHMs having same frequency. So it's an SHM. Second one, is it an SHM? Let's talk about second one. Y is equal to sine cube of omega t. Now we have this formula, sine cube of theta. So sine cube theta equals to 3 sine theta minus sine 3 theta upon 4. Okay, so here we have theta equals to omega t. So if we write sine cube of omega t, we'll get what? 3 sine of omega t minus sine 3 of omega t with this factor. Okay, so now here frequencies of this one and this one, they are different. Frequencies are not same, right? So frequency of the second term is 3 times as much than the first term. Okay, so this will be some periodic function. Okay, so let's suppose time period for first one. Okay, first function is suppose t. The time period of second function. Okay, second function will be what? T by 3, because frequency is thrice. Okay, but see, when this function, okay, sine omega t, it completes one oscillation, this one will complete 3 oscillations. This will be still periodic, but it's not SHM because frequencies are different. Okay, then this one, it's SHM. This is clear. Okay, it has got frequency of 3 omega. Okay, this is SHM. This is not SHM. What's the answer? First one is SHM. Fourth one, sorry, not fourth one. Third one is SHM. So option C is the answer. Right. Option C is the answer. Two SHMs with same amplitude and time period, when acting together in perpendicular directions with a phase difference of pi by 2, give rise to straight motion, elliptical motion, circular motion, none of these. Option C, circular motion. Okay, let's start. So option C, circular motion. Can you tell me how? If we think of circular motion of an object, right? If we think of circular motion of this object, and we had discussed this, that if we resolve its position vector along two components, okay, I'm sorry, this x, this is y, okay. So we had discussed this, that x is equal to what? This angle is suppose theta, that's omega t. So x is equal to r cos of omega t, and y is equal to r sine omega t. So it's like this, okay, x and y, these are two SHMs, right? They are acting perpendicular to each other, and how much is phase difference between them? So we can see phase difference is pi by 2. Okay, so these two combined SHMs, they give rise to what? They give rise to circular motion. We can think of it in this way also. If we square this and add, okay, if we square this and this, what will we get? X square equals to r square cos square omega t, and y square equals to r square sine square omega t. If we add them, so x square plus y square is equal to, we can take r square common, cos square omega t plus sine square omega t. Okay, so that's one. So x square plus y square is equal to r square. Okay, so this is a circle, right? The composition of two simple harmonic motions of equal periods at right angles to each other and with a phase difference of pi results in the displacement of particle along a circle, figure of 8, like this. Okay, straight line or ellipse. Now, can you tell me? So composition of two simple harmonic motions of equal periods. That means frequency is same. Okay, uh, they are acting right angles to each other and with phase difference of pi now, not pi by 2. I'm sorry. So we can write x is equal to a sine of omega t, y is equal to what? A multiplied by sine of omega t plus pi. Okay, so it is sine omega t cos pi plus cos omega t sine pi, right? And sine pi is 0, cos pi equals to -1. That means this is minus a sine omega t. Okay, so now if you, okay, so see here, y is equal to minus a sine omega t, x is equal to a sine omega t. So what will be relation between them? You can say y is equal to minus of x. And what is this thing? It's a straight line, right? Equation of straight line is y equals to mx plus c. Okay, so consider c equals to 0 and m is -1. Okay, so this is equation of straight line. So what's the answer? Option C, straight line. Got it? Yes, no. Which one of the following equations of motion represents simple harmonic motion? I'm sorry. Okay, tell me. Acceleration equals to minus k x plus a. Acceleration equals to k x plus a. Acceleration equals to kx, and acceleration equals to minus k naught x plus k1 into x square. Which one of these represents simple harmonic motion? So option A, right? Okay, because you want a force which is always directed towards the mean position. So here, let's suppose mass is equal to 1. So force is minus k times x plus a. Okay, that is minus ka minus kx. Okay, or here you can say the mean position is a, x equal to a, right? Okay, the mean position itself is x equal to a, and this force is directed towards that position. Okay, so option A is the answer. This is simple. Now the questions that we are going to discuss are all simple. See, this one, a particle executes SHM along x-axis. The force acting on it is given by. Tell me, it's option D. See, in option C, what is the problem? Here, force goes on increasing. The restoring force goes on increasing as x increases. That means there will not be any restoring. Okay. On the contrary, it pushes that object. Okay, it pushes that object away from the center. Okay, so C cannot be an answer. Only option D. Particle of mass m is released from rays and follows a parabolic path as shown. Assuming that the displacement of mass from the origin is small, which graph correctly depicts the position of particle as a function of time? So see, particle is released from here. Okay, that is from this position. So which is the answer? Then because potential energy function is like this, it will perform simple harmonic motion. Okay, so which one is answer? Option A is position versus time graph of simple harmonic motion. Option D is position versus time graph for simple harmonic motion. Which one is correct? Simple. Has to be option A, right? It is option A because particle is starting from here. It's starting from extreme position, not from mean position. Okay, so it's option A. The particle executing simple harmonic motion has a kinetic energy k naught cos square omega t. The maximum values of the potential energy and total energy are respectively A is k naught upon 2 and k naught, B is k naught and 2 k naught, C is k naught and k naught, and D is 0 and 2 k naught. Tell me the maximum values of potential energy and total energy. Let's do one thing. This is kinetic energy is given by k naught cos square omega t. It's option C, right? It's option C. Okay. So why so? Why so? So kinetic energy is given by this formula k naught cos square omega t. So now you can compare this with some x, which is if x is a sine omega t, okay, then v will be a omega cos of omega t, and then if you square this, okay, then v square will be square of this a square omega square cos square omega t, right? And the formula of kinetic energy will have cos square omega t term. Okay, so then you can, I'm sorry, you can compare this. Okay, so let's do this. So it is half of, let's take half of mv square. It will be equal to half of m multiplied by a square omega square cos square omega t, right? So this half of m omega square a square, this is the total energy. So k naught is equal to this thing. Okay, so k naught is equal to half of m a square omega square, and this is equal to total energy, right? And the maximum value of potential energy just equal to total energy. So total energy is also k naught, and maximum value of potential energy is also k naught. Okay, that's why it is option C. See, the potential energy is given by this thing half of m omega square x square, right? What is the maximum value of potential energy when x is equal to a? Okay, it is half of m omega square a square. And what is maximum value of kinetic energy? It is also same. Okay, when x is 0, kinetic energy will be maximum. It is half of m omega square a square. Okay, and total energy is also that much, half of m omega square a square, right? So now in our problem, what is the maximum value of kinetic energy? This is the problem. Huh. What is the maximum value of kinetic energy? It's k naught, right? So maximum value of kinetic, because maximum value of cos square omega t, okay, it's 1. Therefore, the maximum value of kinetic energy is k naught. It must be equal to total energy. Okay, so total energy is equal to k naught, and the potential energy is also equal to maximum value of potential energy is also equal to k naught. The potential energy of a simple harmonic oscillator when the particle is halfway to its end point is, now E is supposed to be total energy. Okay, so in comparison with that, what is potential energy when particle is halfway to its end point? So we know that potential energy is half of k into x square. Total energy E is half of k into a square. So when x is equal to a by 2, how much would be potential energy? Half of k into a by 2 square. Okay, that is a square by 4. Okay, So that 1 by 4 I can take here. So it's 1 by 4 multiplied by half of k into a square. And what is this? This is equal to e. Okay, so it's 1/4. It is 1/4 of e, right? So option C is the answer. Let us see this question. This is from 2003. A particle of mass m oscillates with simple harmonic motion between 2 points x1 and x2. The equilibrium position being 0, its potential energy is plotted. It will be as shown below in the graph. This is very simple, straightforward. So option A. Okay. Next one, the displacement between maximum potential energy position and maximum kinetic energy position for a particle executing simple harmonic motion is. So yes, tell me, is it plus minus a by 2, plus a, or plus minus a, or minus 1? Option C, right? It's option C. See, because okay, displacement between, or you can say difference between maximum potential energy position and maximum kinetic energy position for a particle executing simple harmonic motion is. Okay, so see, we consider a particle which is oscillating like this, performing simple harmonic motion. This is plus a. Okay, let's use small a. This is minus a, and this is 0. Okay, so now if you take maximum potential energy, so it is at this position and it is at this position. So if you subtract uh, okay, x equal to minus a, sorry, if you subtract 0, okay, at 0 kinetic energy is maximum, Ke is maximum, right? So you subtract this position from minus a. What do you get? Minus a minus 0 is minus a. Okay, and if you subtract it from plus a, then you will get plus a. Okay. So these are the two positions where potential energy is maximum. Okay, so that's why it is plus minus a, right? Next question, the total energy of particle performing simple harmonic motion depends on, so Kam, Ka, Kax, Kx. Total energy can be written as half of m omega square a square. Okay, so in this case you can say it depends on m, omega, and a, right? So it depends on m. Okay, and it can be also written as half of k into a square. So if k and a is given, there is no need of m. But if k is not given, then you need m, omega, and a. Okay, right? But if k is given, we don't need m. So k is answer. Okay, option B is the answer. A linear harmonic oscillator of force constant 2 multiplied by 10 raised to 6 newtons per meter and displacement 0.01 meter has a total mechanical energy of 160 joules. Its potential energy, okay, we have to calculate potential energy, and it is simple, right? So force constant is given, displacement is given, potential energy is equal to half of k times x square. This is just plug and play kind of problem. Half of k, 2 multiplied by 10 raised to 6 multiplied by displacement is 0.01. Okay, I can write that as 10 raised to minus 2, and we have square of that. Okay, so this 2 and this half gets cancelled. Okay, so we have 10 raised to 6 multiplied by 10 raised to minus 4, that's 10 raised to 2. Okay, 10 raised to 2, 100. So 100 joules is answer, option C. So in simple harmonic motion, when the displacement is one half the amplitude, what fraction of total energy is kinetic? So we have just found that when displacement, yes, so in a simple harmonic motion, when the displacement is one half the amplitude, what fraction of total energy is kinetic? So can you tell me the answer directly? It's option B, right? Because potential energy is 1/4, remaining is kinetic energy. Okay, so we just calculated, right? Potential energy given by half of kx square, x is equal to a by 2. Okay, squaring that, we get what? It is 1/4 of half of k into a square, which is E. Okay, so it is E by 4. This is potential energy. We want kinetic energy. So it is total energy E minus potential energy U. Okay, this E minus E by 4. That is 3E by 4. Okay, so what fraction of total energy is kinetic? It is 3/4. A loaded vertical spring executes simple harmonic motion with a time period of 4 seconds. The difference between the kinetic energy and potential energy of the system varies with a period of 2 seconds, 1 second, 8 seconds, or 4 seconds. So see, it is performing simple harmonic motion, right? It is performing simple harmonic motion. And if we talk about the potential energy and kinetic energy in simple harmonic motion, so we have this kind of a curve. Okay, this kind of a curve. Now they are saying if we take difference of this, okay, difference between potential energy and kinetic energy. So what? Sorry, what kind of graph we'll get? Or see, both of these, okay, they are periodic. They are periodic with period of t by 2. Okay, see, potential energy and kinetic energy. So if period of SHM is this much, it's T, then the period of potential energy and kinetic energy is how much? It's T by 2. Okay, so even if you take the difference, because both of these are periodic with period equal to T by 2, the difference is also periodic with period equal to T by 2. Got it? Yes, no? And that's why here time period was 4 seconds. Okay, time period of SHM is 4 seconds. So time period for difference between the potential energy and kinetic energy, or kinetic energy and potential energy, okay, if you take difference of those, so this function k minus u, this is also a periodic function, okay, is periodic with period t by 2. Okay, because both of these are separately periodic with period t by 2. So even if you take difference, their period will be same. Okay, its period will be same. Okay, and that's why the answer is what? T is 4, so it is 4 divided by 2. Okay, 2 seconds. Option A. Let's see next question. A body executes simple harmonic motion with an amplitude A. At what displacement from the mean position is the potential energy of body is 1/4 of its total energy? So this is repeated. Tell me, the question is, at what displacement from mean position is potential energy 1/4 of total energy? So potential energy U is equal to what? E by 4. Okay, this is given. So half of K into X square is equal to 1/4 of half of K A square. Okay, this is E. Half K A square is E, right? So then, okay, this K and K gets cancelled. Okay, half and half gets cancelled. X square is equal to A square by 4. So X is equal to A by 2, right? The angular velocity and the amplitude of simple pendulum is omega and small a respectively. At a displacement x from mean position, if its kinetic energy is T and potential energy is V, then the ratio of T to V is ratio of kinetic energy to potential energy is. So that is simple, right? Kinetic energy is half of, okay, I'm sorry. Yeah. So you see here it's a square minus x square is there, right? So we can use this formula for kinetic energy. It is half of k multiplied by a square minus x square. Let's use small a. Okay, half of k multiplied by a square minus x square. And formula for potential energy is half of k multiplied by x square. So this half k and half k gets cancelled. So what is left? It's option C. Okay, this is equal to a square minus x square divided by x square. Right, it's option C. A pendulum is hung from the roof of sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. The acceleration of bob of the pendulum is 20 meters per second squared. Okay, acceleration is given at a distance of 5 meters. So distance is given, okay, from the mean position. The time period of oscillations is very simple, right? Just use a equals to minus omega square x, but we just want magnitude. That's why I'm writing a equals to omega square x. Okay, so it is 20 equals to omega square multiplied by displacement is 5. Okay, that means omega square equals to 20 upon 5, that's 4. So omega equals to 2, and we want time period. So this is 2 pi upon t equals to 2. 2 gets cancelled. T equals to pi is the answer. Body of mass m is attached to the lower end of a spring whose upper end is fixed. Okay, the spring has negligible mass. When the mass m is slightly pulled down and released, it oscillates with time period of 3 seconds. So time period is 3 seconds. When m is increased by 1 kg, then period of oscillation becomes 5 seconds. The value of m in kgs is, okay, so when m is increased by 1, t becomes what? 5 seconds, right? So we have T equals to 2 pi square root of m upon k, right? This formula we have. So T1 by T2, I can say T is directly proportional to root m. So T1 by T2 equals to m1 by m2. Sorry, root of m1 upon m2. So at first you have mass m only. Second time you have m plus 1 kg. Okay, m plus 1 kg. Right. So then we can square this. So this is 3 by 5 equals to root m upon m plus 1. Squaring this, we will get 9 by 25 equals to m upon m plus 1. That means 9m plus 9 equals to 25m by cross multiplication. So 9 equals to 16m. So m equals to 9 upon 16. Okay. So it's option D. All right. Next question. So the period of oscillation of a mass m suspended from spring of negligible mass is T if along with it mass m is also suspended. So now mass is made 2 times. Okay. The period of oscillation will now be. So this is simple. It will be root 2 times T, right? Because T2 by T1 equals to what? So because T is proportional to root of m, okay, so we can say it is m2 by m1. It's equal to root of m2 by m1. So that is 2m upon m. So this thing will get cancelled out, m and m. So T2 equals to root 2 times T1. Okay, option D. A simple pendulum performs simple harmonic motion about x equal to 0 with an amplitude A and time period t. Okay, amplitude is given, time period is given. The speed of pendulum at x equal to a by 2 will be. So speed is given by omega square root of a square minus x square. Okay, omega can be written as 2 pi upon t. Okay, and x is what? Because there is t in all the options. Okay, so a square minus x square, which is a by 2 square. So it is a square minus a square by 4. Okay, so it is 3a square by 4. It's 2 pi divided by t. So if you take square root, you get v equals to 2 pi upon t multiplied by root 3a upon 2. 2 and 2 gets cancelled. So it is root 3 pi a upon t. V is option C, right? Okay. So question on spring constants. A spring of force constant K is cut into lengths 1 is to 2 is to 3. Okay. So it is cut into lengths 1 is to 2 is to 3. They are connected in series and the new force constant is K prime. Okay. So see, this is your spring. You cut it in the ratio 1 is to 2 is to 3. Right. Suppose this is 1 is to 2 is to 3. So this is K1, this is K2, this is K3. Spring constant of this one is K1, K2, K3. So how much will be K1? So add this 3. So it is 1 by 6th. Right. This length is 1 by 6th. That means spring constant will be what? K1 is equal to, okay, you can say L1 equals to L by 6, L2 equals to 2L by 6, and L3 equals to 3L by 6. So spring constant is inversely proportional to length. So K1 equals to what? 6 times K. It is equal to 6 times K, right? Okay. K2 equals to 6 by 2 times K. Okay, just invert this number. K2 equals to 6 by 2, that means 3, 3 times K. And K3 equals to 6 by 3, okay, that is 2, 2 times K. Is this clear? After that, you connect them in series. My question is, you break it like this, okay? You cut it and you connect it. So it's like it's like restoring the previous case. Okay, you take a spring, you cut it, and again you join it. There won't be any change in the spring constant. So I don't want to solve for series combination. K dash is just equal to K. Even if you solve, you will get same. Okay, using formula for series combination. Then K double dash will be equal to what when they are connected in parallel. So K double dash is equal to K1 plus K2 plus K3. It is 6K plus 3K plus 2K. 6 plus 3 plus 2 is 9 plus 2, 11. Right. So it is 11K. Okay. And then if you take ratio, K dash is to K double dash equals to K upon 11K or 1 upon 11. Right. It's option B. Next one. A mass of 2 kg is put on flat pan. Okay, there is a flat pan like this, and this mass is kept on it, attached to a vertical spring on the ground as shown in the figure. Okay, then the mass of the spring and the pan is negligible. Mass of the spring and the span, it's negligible. When pressed slightly and released, the mass executes a simple harmonic motion. The spring constant is 200 newtons per meter. What should be the minimum amplitude of motion so that the mass gets detached from the pan? Okay, take g equals to 10 meters per second square. Okay, 1 minute goes in reading the question itself. Anyways, so what will happen? At what position will it get detached? So now suppose you press it and release. What will happen? There are two forces acting on it, right? There are two forces acting on it. One is the spring force, that's upwards, and another is gravitational force, it's downwards. Okay, so it will stay connected to the pan till the time both the forces are equal. I mean, the maximum spring force can be equal to the gravitational force, right? So you can say kx should be, okay, less than or equal to gravitational force. Till that time it will be attached. Once it exceeds the gravitational force, it will get detached from the pan. Okay, so k is 200. We want x only. Okay, so this is 200 times x is greater than or equal to mg. M is 2, 2 multiplied by 10. Okay, this is my x. Okay, so take 200 on other side. So it's 20 upon 200 is zero point 0.1. So x is greater than or equal to 0 0.1 meter. Okay, options are in centimeter. So you can convert this in centimeter. 0 0.1 multiplied by 100 centimeters. Okay, so it is greater than or equal to 10 centimeters. Right? Option A. A rectangular block of mass m and area of cross section A floats in liquid of density rho. if it is given a small vertical displacement from the equilibrium, it undergoes oscillation with time period t. Then, okay. So when you dip a block, okay, when you put a block in a liquid, okay, if it floats, that means its density is less than density of liquid, right? This is from Archimedes, okay. So suppose we have this block, we are putting it in liquid, some liquid, and it floats, okay. So suppose it's this much length gets immersed in liquid, okay, this much length it gets immersed, okay. So there is always an upward force acting on it due to the liquid, because of which it flows. And how much is that upward force? It is equal to mass of the volume of the liquid which gets displaced because of this block, okay. This is Archimedes principle, Archimedes law of buoyancy, okay. So now see, the upward force equals to force due to buoyancy. So the spelling is, I guess, Buoncy, right? And it is given by, it's equal to the weight of the liquid displaced, okay. So how much is that? It is density multiplied by volume. So this much would be volume. This is suppose area. This much length is L. It is A into L multiplied by. So this is volume that is immersed in liquid. Okay. So that much liquid gets displaced. Okay. And the force due to buoyancy is equal to what? Weight of the liquid displaced by any solid. Okay. So this is volume. Volume multiplied by density will give us the weight. Now, on top of this, if you give a small vertical displacement, so if you push it further, what will happen? So you are pushing it, the water or that fluid, it will resist that change. Okay. So suppose you push it by displacement x. So now excess force due to buoyancy will be how much? So excess force due to buoyancy is equal to, I can say, let's call it F. It's equal to A multiplied by that displacement. Okay. This much is the extra volume that you are inserting inside the liquid multiplied by rho. Okay. And if the displacement is downwards, that force is upwards. That's why we can put negative sign like this. Okay. So now this is equivalent to, okay, F is proportional to minus x, right? More you push, more excess force will be there due to buoyancy, okay. And because of that it will oscillate, right? So we want to find time period of that oscillation. So now time period of oscillation is given by 2 pi square root of m by k. And now what is k here? So if you compare this with f equals to minus kx, okay, if you compare this with f equals to minus kx, so k is equal to a multiplied by rho, right? So this term in multiplication with x, a into rho is equal to k. So you can put that and you get t equals to 2 pi square root of mass of the solid, okay, mass of the block upon a rho. So this is time period. Now you can tell, is it inversely proportional to root m? No. Is it directly proportional to rho? No. Okay, square root of rho? No. It's inversely proportional to root of rho. Is it inversely proportional to root A? Yes. Okay, it is inversely proportional to root A. So option C is the answer, right? Not option D. Okay, next one. Two springs of spring constant K1 and K2 are joined in series. The effective spring constant of the combination is given by. This is very simple, right? So option D is the answer. Okay, because 1 upon Ks is equal to 1 upon K1 plus 1 upon K2. This can be written as, so if you make denominators same, you have to multiply this by K2 and this one by K1. So it is K2 upon K1 K2 plus K1, and then you take reciprocal, so you get Ks equals to K1 K2 upon K1 plus K2. Option D. Next question. The time period of a mass suspended from a spring is T. If the spring is cut into 4 equal parts, okay, it is cut in 4 equal parts and same mass is suspended from one of the parts, then the new time period will be. Tell me. Spring is cut into 4 equal parts, right? 4 equal parts. So if you take any one of those, let's call it K1, it will be equal to what? 4 times K, right? Because it's inversely proportional to length, and you have T equals to 2 pi square root of m by K. This is the formula. Okay, so you can say T2, okay, or let's call it T1. So after cutting the spring and taking one of those parts, okay, then you get time period T1 equals to 2 pi root of m upon K1, which is 4 times K, so which is 2 pi square root of m upon 4K1. Okay, so you can take root of 4, that's 2, so you get 1 by 2 of T, or T by 2, right? 1 by 2 multiplied by 2 pi root of m by K. Sorry, I wrote 4K1, it's 4K. Right, so it is option C. Mass is suspend a mass is suspended separately by two different springs in successive order. Then time periods is T1 and T2 respectively. Okay, so time period, if you suspend it with this first spring, is T1. For second spring, it is T2. If it is connected by both springs as shown in parallel combination in figure, then time period is T0. The correct relation is, okay, let's find. So T1 can be written as what? 2 pi root of m by K1. T2 can be written as 2 pi root of m upon K2. And what about T0? T0 equals to 2 pi root of m upon, when you connect both of them in parallel, so net spring constant becomes K1 plus K2. So K1 plus K2, right? So then what we can do is we can square these, okay? So T1, right? So yeah, what we can do is we can write T1 equals to 4 pi square multiplied by m upon K1, or okay, or K1 equals to 4 pi square m divided by T1. Similarly, K2 equals to, okay, K2 equals to what? 4 pi square m upon T2. I'm sorry. Okay. Then you can square this one also. So we get K1 plus K2 is equal to 4 pi square m divided by T naught. Okay. It's pi square. So you can substitute for K1 and K2 from here. Okay. In this formula. So what do we get? We get 4 pi square m divided by T1 plus 4 pi square m upon T2 is equal to 4 pi square m divided by T naught, right? So this 4 pi square m gets cancelled. 1 upon T1 plus 1 upon T2 is equal to 1 upon T naught. 1 upon T naught is equal to 1 upon T1 plus 1 upon T2. So it is option C, right? Yeah, matches with option C. Okay, just little calculation, right? Okay. Next question. Two masses M1 and, sorry, not M1, two masses, okay, two masses MA and MB are hung from two strings of lengths LA and LB respectively. They are executing SHM with frequency relation FA equals to 2 times FB. Then the relation LA equals to LB by 4 does not depend on mass. Okay, so does it depend on mass? SHM, you don't have spring, you have strings. Okay, so mass is hung with a spring, sorry, not spring. Mass is hung with a string and it oscillates like this. Then time period is given by what? 2 pi square root of L upon G, right? Does not depend on mass. Okay, it's not spring, it's a string. Okay, so it does not depend on mass. So these two options are not relevant. So FA equals to 2 FB. Yeah. So time period is directly proportional to root of L, right? FA equals to 2 FB. Okay, you want frequency. So frequency is inversely proportional. Okay. So FA equals to 2 times FB. Okay. It's inversely proportional to length. So you can say, okay, FA equals to some constant multiplied by 1 upon root LA. It's equal to 2 times 1 upon root LB, because frequency is inversely proportional to root of L. Time period is directly proportional to root of L. Okay. So therefore you get, you can square it. So you get 1 upon LA equals to 4 times 1 upon LB, or LB equals to 4 times LA. Okay, or LA equals to LB upon 4, which is option A, right? It's option A, right? Bob of simple pendulum having length L is displaced from mean position to angular position theta with respect to vertical. Okay. If it is released, then the velocity of bob at the equilibrium position. Okay. So you have this angle is theta, this length is L, this length is L. Okay. So when this bob comes from here to here, how much will be its velocity? This is the question. When it is released, then velocity of bob at equilibrium position is. So you have to find this height. So velocity equals to square root of 2gh. Okay, I'm using, let's use small h only. Okay, so how much would be this h? It is this much length minus this much length. How much is this length? This length is, if you think about this triangle, okay, so let's call this A, this point B, and this is C, suppose. Okay, so we want length AB, and this is D. Okay, so in this triangle, you can say cos of theta equals to AB divided by AD, or it is AB divided by L. So AB is equal to what? L cos theta, right? So you want H. H is equal to L minus L cos theta, this length. Okay. So V equals to root 2 G multiplied by L minus L cos theta, or you can take L common also. If you take L common, it is 1 minus cos theta. It's option A. Time period of a simple pendulum is 2 seconds. If its length is increased by 4 times, then its time period becomes. This is very simple. T equals to 2 pi root of L by G. If length becomes 4 times, time period becomes twice, because it is directly proportional to root of L, right? So length becomes 4 times. Okay, so let's say, I'm sorry. So T1 equals to 2 pi root of L1 by G. T2 equals to 2 pi root of L2 by G. And L2 equals to 4 times L1. So it is 2 pi root of, okay, 4 times L1 upon G. So take square root of 4. It is 2 multiplied by, so T is equal to 2 times 2 pi root of L1 by G. That is 2 times of T1. Okay, T1 is 2 seconds. So T2 is 2 times that, 4 seconds. Two simple pendulums of length 5 meter and 20 meter respectively are given small linear displacement in one direction at the same time. They will again be in phase when the pendulum of shorter length has completed how many oscillations? Okay, so this is a simple question, right? So the lengths are in ratio 1:4. Okay, so T is equal to 2 pi root of L by G. So T is directly proportional to, it's directly proportional to root of L. So T1 by T2 equals to root of L1 by L2. So it is root of 5 by 20. Okay, or 1 by 4. That's 1 by 2. Okay, so when okay, so T2 equals to 2 times T1. So when the first pendulum completes 2 oscillations, then second pendulum will complete 1 oscillation. And question is, they will again be in phase. Okay, that means if they start from same position, when will they come back at the same position? When the first pendulum has completed 2 oscillations, because only then the second one will complete 1 oscillation and come to the same position, right? So answer is option A. First one completes 2 oscillations. Mass M is vertically suspended from a spring of negligible mass. The system oscillates with frequency n. what will be the frequency of system if mass 4m is suspended from the same spring? Okay, so frequency, okay, frequency n is equal to, it's 1 upon 2 pi square root of k by m, right? 1 upon 2 pi square root of k by m, inversely proportional to root of m. So if m is made 4 times, right? M is made 4 times. So what will happen to the frequency? So n dash equals to 1 upon 2 pi root of k upon m dash, which is 4m. Okay, take square root. So square root of 4 is 2. It's 1 by 2 times 1 upon 2 pi root of k by m, which is n, right? 1 by 2 times of n, or n by 2. Let's see next question. If the length of simple pendulum is increased by 2%, then the time period. This is very, very simple. Actually, we have seen this in units and dimensions. Okay, so t equals to 2 pi root of L upon G, or you can say it is equal to some constant multiplied by L raised to half. Okay, then therefore it depends on what? L to the power half. So percentage change, okay, percentage change in t is equal to what? It is equal to half of percentage error or percentage change in length. And how much is that? This is 2%. So it is half of 2. That's 1. Okay. It increases by 1. Right. It's option A. A simple pendulum with a bob of mass m oscillates from A to C. It oscillates like this from A to C and back to A, such that PB is h. This much distance is h. If acceleration due to gravity is g, then the velocity of the bob as it passes through B is. So very simple. Actually repeated. Okay. V equals to square root of 2gh. The body of mass 5 kg hangs from a spring and oscillates with time period of 2 pi seconds. Okay. If the ball is removed, the length of the spring will decrease by. Okay. So there is a body of mass 5 kg hangs from the spring, okay, with time period of 2 pi seconds. So we know t equals to 2 pi square root of m by k, right? M is 5. So t is 2 pi. This is equal to 2 pi root of 5 by k. Okay, so 2 pi gets cancelled. So 1 equals to root of 5 by k. That means k equals to 5. K equals to 5 newtons per meter. Then if this ball is removed, okay, the length of spring will decrease by. So now in equilibrium, what will happen? We can say that mg, whatever is mass is 5 kg only, mg is equal to, okay, the downward force is equal to upward force. So it is equal to kx. So put the values, okay. So 5 multiplied by g is 9.8. Yeah, but in options it is g by k, k by g. So let's keep g as it is. Okay, so 5 times g is equal to k times x, that is 5x. 5 gets cancelled, x is equal to g. So when ball is there, okay, the spring gets elongated by x. Okay, if it is removed, the length of the spring it will decrease by what? It will decrease by x. Okay, x which is equal to g meters. Option D. Next question. The second pendulum is mounted in a rocket. Its period of oscillation will decrease when the rocket is moving down with uniform acceleration, moving around the Earth in geostationary orbit, moving up with uniform velocity, moving up with uniform acceleration. So tell me. Okay, so time period is given by what? 2 pi square root of L upon G. Okay. And so you want time period of oscillation to decrease. That means now length is constant, length will remain as it is. The effective value of acceleration due to gravity. Okay. If it increases, then the time period will decrease. When will it increase? So see, the effective force, okay, the effective force on that pendulum, if it increases, okay, suppose this is a rocket and there is a compartment, okay, there is this pendulum here, okay. So what will be the force? So there will be tension in the string, okay, that is the force, okay, that is the force acting on that pendulum, and gravitational force mg downwards. So now see, so the tension will determine the effective value of acceleration due to gravity. Okay, so you want it to increase. So now that's why it must move with upwards acceleration. Okay, because then only this is tension. Okay, so then only you can say m into a, which is in upward direction. It's total upward force minus total downward force, that's mg. T is equal to ma plus mg, or you can say it is equal to what? M multiplied by a plus g. So this is effective value of the acceleration due to gravity which it will feel. Okay, so m into g dash you can say. So when it moves upwards with some acceleration, then only this g dash will be what? It will be greater than g. And when g dash is greater than g, in that case only time period will decrease. Okay, so don't get confused with t and t. This is tension, this is time period. Okay, is it clear? So it's option D. Next question. A simple pendulum is suspended from roof of a trolley which moves in horizontal direction with an acceleration a. Then the time period is given by t equals to 2 pi square root of L upon a dash. T equals to 2 pi square root of L upon a dash. Okay, a prime, where a dash is equal to. So yeah, this is also simple. So there is some horizontal acceleration a, and acceleration due to gravity is downwards. Okay, right. So again, what will be effective acceleration? What will be effective acceleration? They are calling it a dash. Okay, so a dash will be equal to what? I mean, a dash square will be equal to a square plus g square, right? So a dash will be equal to square root of a square plus g square. Okay, yes, it is option D. Got it? Yes, no? This is clear, no? The mass m is suspended from two coupled springs connected in series. The spring, the force constant for springs are K1 and K2. The time period of suspended mass will be, okay, coupled spring means they are connected, okay, they are connected in series, it's given, right? So in series combination, find out Ks, it is equal to K1 K2 upon K1 plus K2. If there are only two springs, okay, using this formula 1 upon Ks is equal to 1 upon K1 plus 1 upon K2, right? So using this only we can find out Ks is equal to K1 K2 divided by K1 plus K2, and time period will be equal to what? 2 pi square root of m by k, which in this case will be Ks, the effective spring constant of the series combination, which is 2 pi square root of m upon Ks is K1 K2 divided by K1 plus K2. So divided by K1 plus K2. Okay, K1 plus K2 is in denominator of denominator, so it goes in numerator. Right. So it is option D. Right, very good. It's option D. Okay. When an oscillator completes 100 oscillations, it its amplitude reduces to one third of initial value. What will be its amplitude when it completes 200 oscillations? Okay. So this is simple. See, now within 100 oscillations, it reduces to one third of the original value. After 200 oscillations, what will happen? It will reduce to one third of one third, right? Okay. This is another 100 oscillations, you can say. Okay. So it will reduce to one third of one third, that is 1 by 9 is the answer. You can solve this if you like. After some time, what happens? Okay, so let us write down an equation of amplitude of damped harmonic oscillator. So A at some time t, A at some time t is equal to A multiplied by e raised to minus b upon 2m into t, or we can just write minus gamma t. Okay, gamma is called as decay rate. Okay, see, now after 100 oscillations, so t is equal to what? T is equal to 100 times t. What happens? You get amplitude equal to a by 3. So a by 3 is equal to a multiplied by e raised to minus of, okay, 100 gamma capital T. So you want to find what happens when t is equal to what? 200 times t, right? So it is a at that time is suppose 80, it is e raised to minus 200 gamma t. Then you can divide these two. Okay, so actually this thing and this thing gets cancelled. It is 1 by 3 equals to e raised to minus 100 gamma t. Okay, so you can write 3 is equal to e raised to 100 gamma t, right? So 3 equals to, or e raised to 100 gamma t equals to 3. Okay, and you can substitute that here. Okay, so I can say 80 upon a, or let's write a upon 80 is equal to e raised to 200 gamma t. Okay, or this is equal to e raised to 100 gamma t square, that is 3 square, right? What is 3 square? 3 square is 9. Okay, so A upon AT is equal to 9, and that means AT equals to what? A upon 9. So option D is the answer. Next question. In case of a forced vibration, the resonance peak becomes very sharp when the option A, damping force is very small, damping force is small, restoring force is small, applied periodic force is small, and quality factor is small. Okay, so what is quality factor? Actually, it is F naught divided by 2 times delta F. What is delta F? Delta F is the particle with restoring force proportional to displacement and resisting force proportional to velocity is subjected to a force F sine omega t, right? So there is restoring force proportional to displacement, that is minus kx, and resisting force, which is damping force, it's proportional to velocity, minus bv. Okay, it is subjected to this force. This is the external force, external periodic force F sine omega t. If the amplitude of particle is maximum for omega equals to omega 1 and energy of particle is maximum for omega equals to omega 2, okay, then omega naught is the natural frequency of oscillation of particle, right? So what will be the answer of this? Omega 1 is not equal to omega naught and omega 2 equals to omega naught. Omega 1 is equal to omega 0 and omega 2 equals to omega 0. Omega 1 equals to omega 0 and omega 2 is not equal to omega 0, or omega 1 is equal not equal to omega 0, omega 2 not equal to omega 0. Tell me what will be the answer. So this is simple actually. Amplitude is maximum at omega 1 and energy is maximum at omega 2. So what is energy? What is energy in SHM? Half of Ka square. Sorry. Okay. So when amplitude is maximum, then only energy will be maximum, right? When amplitude is maximum, then only the energy will be maximum. Okay. So amplitude is maximum at omega 1, right? And energy is maximum at omega 2. So these two frequencies must be equal. Yes, no? Okay. And resonance will happen when natural frequency matches with the frequency of external periodic force, and therefore it should be equal to what? Okay, the frequency at which amplitude becomes maximum and energy becomes maximum, it should be equal to the natural frequency of oscillation of the particle. All right, next question. So there were very few questions in NEET exam based upon resonance, based upon damped harmonic oscillator, and also on forced harmonic oscillator. So we'll discuss some questions from some other exams. Okay. So the equation of damped simple harmonic motion is this thing. We know this equation: m d2x by dt square plus b dx by dt plus kx is equal to 0. Then the angular frequency of oscillations is. So this thing, you know, it is direct question. Tell me what is the answer. Okay, this frequency we have to remember. Omega dash is equal to what? Square root of k by m square, sorry, not k by m square, k by m minus b upon 2m square. Okay, so what's the answer? So option A, right? So let's see next question. In case of forced vibration, the resonance wave becomes very sharp when, okay, this is copy pasted from uh, the NEET exam only. Okay, so it's option C, when damping force is small, right? Next question. During the phenomenon of resonance, the amplitude of oscillation becomes large, the frequency of oscillation becomes large, the time period of oscillation becomes large, all of the above. Which is the answer? Okay, option A is the answer. But second and third, if frequency becomes large, then what will happen to time period? It will become small, right? So both cannot be large at the same time. So, okay, this is contradictory, right? But in resonance, so resonance is defined with respect to amplitude only. The amplitude becomes large, okay, that is phenomenon of resonance. Let us see next question. If differential equation is given by, this is the differential equation, d2i by dt square plus 2k dy by dt plus omega square y equals to f naught sine pt describe the describes the oscillatory motion of a body in dissipative medium under the influence of periodic force. Then the state of maximum amplitude of oscillation is a measure of. Tell me. Okay, it's measure of resonance. Maximum amplitude, right, happens in resonance. Let us see next question. The amplitude of damped oscillator decreases to 0.9 times its original magnitude in 5 seconds. In another 10 seconds, it will decrease to alpha times its original magnitude, where alpha equals. Okay, so see, again, we'll just think about it. Okay, we can solve this question by a little bit of thought only. No need to solve it actually. Okay, using numerical calculations. So see, in 5 seconds, what happens? It becomes to, the amplitude decreases to 0.9 of the original value. So in another 10 seconds, so another 10 seconds means twice of 5 seconds, right? 2 times 5 seconds. So another 5 seconds, what will happen? It will become 0.9 of 0.9. In another 5 seconds, it will become 0.9 of this thing, 0.9 square, right? And then we just need to solve this. So it is 0.9 cube, or 0.9 multiplied by 0.81, we can say. Okay, 0.81 multiplied by 0.9. 729 is the answer, right? Option C. Okay. Okay, let's see next question. The displacement of a damped harmonic oscillator is given by this equation. Here t is in seconds. Time taken for its amplitude of vibration to drop to half of its initial value is close to. This is from JE. Okay, it's a simple question. So this kind of question can be asked in NEET also, right? So x of t is equal to not 0, e raised to minus zero point 0.1 t multiplied by cos of tan pi t plus phi. Okay, so what is amplitude? This is the amplitude, right? So amplitude is given by e raised to minus 0.1 t, and this becomes half. It drops half of its initial value. So how much is the initial value? put t equals to 0. Okay, so anything raised to 0 is 1. So this thing raised to 0 is 1. That means initial value is 1, right? Okay, there is no other multiple here, right? So put t equals to 0, this thing becomes 1. So that is the initial amplitude. Okay, so at some time, what happens? It becomes half. It becomes half. So half is equal to e raised to minus 0.1 t. So therefore, we can say 2 is equal to e raised to 0.1 t. Okay, what I have done is I have changed this to positive. So we have to take reciprocal of this thing. 2 equals to e raised to 0.1 t. After that, we have to take log of this. Okay, but it will be which log? Natural log, right? So ln of 2 is equal to log of this. Okay, ln of e raised to 0.1 t and 0. Okay, this is anti-function, the log and e raised to something. Okay, exponent and log. So therefore, you can write this as 0.1 t. Ln of e is 1, and then you can convert this to log to the base 10. Okay, we can convert this to log to the base 10. How come? So it is 2.303 multiplied by log to the base 10 of 2. We'll just write it as log of 2. So 0.1 t, this thing multiplied by log of 2. Okay, and we have to remember log of 2. Okay, because it will come here, it will come in radioactivity also, right? So log of 2, okay, we should remember, it will be handy. So log of 2 is 0.3010. Okay, so 2.303 multiplied by 0.3010 is 0.1 t. We can move that 0.1 on left hand side. Okay, so it becomes this thing multiplied by 10. So this thing multiplied by 10 is equal to t. So how much is t? This thing 2.3 times 3. Okay, 69, right? 0.69. 0.69 or 6.9? 6.9. Sorry. So t equals to 6.9 seconds, right? So it is option B. Let us see next question. A damped harmonic oscillator has a frequency of 5 oscillations per second. The amplitude drops to half its value for every 10 oscillations. The time it will take to drop to 1 by 1000 of the original amplitude is close to. Okay, so see, damped harmonic oscillator has frequency of 5 oscillations per second. So its frequency f is equal to 5 hertz. Okay, and its amplitude drops to half its value for every 10 oscillations. I'm sorry. So see, every 10 oscillations it drops to what? Half its value. Okay, T is equal to 1 upon f. Okay, so every 10 oscillations, what is happening? Its value is dropping to half. Okay, so can we say that time taken for, so then the amplitude drops half its value every 10 oscillations. Okay, so in every second it performs 5 oscillations. Okay, so how much time will it take to perform 10 oscillations? 2 seconds, right? So for t equals to 2 seconds, its amplitude drops to half of its value. So then the time it will take to drop to 1 by 1000 of the original amplitude. Okay, so this is given that a by 2 is equal to a into e raised to. So let's write our equation. At equals to a multiplied by e raised to minus gamma t. Okay, so a by 2 is equal to a multiplied by e raised to minus 2 gamma. Right, when t is equal to 2 seconds, amplitude becomes half. Okay, so this thing gets cancelled, a and a gets cancelled. So we get 1 by 2 is equal to e raised to minus 2 gamma, or 2 is equal to e raised to 2 gamma. Right, we can say this. After that, what do we want? We want the time when amplitude becomes 1 by 1000 of the original value. So a by 1000 is equal to a multiplied by e raised to minus gamma t. Okay, so a and a gets cancelled. So we get 1 by 1000 equals to e raised to minus gamma t. Okay, or 1000 is equal to e raised to gamma t. Right. So then what can we do? Yeah, we can take log of this thing itself. Okay, so if we take log of this thing, so ln of this 1000 is equal to ln of e raised to gamma t, and from that we get gamma t is equal to what? 2.303 multiplied by log to the base 10 of 1000 is 10 raised to 3. Right. So we can write, sorry, multiplied by 3 multiplied by log to the base 10 of 10 is 1, and that's equal to gamma t. Okay. Then from this equation, what do we get? We get ln of 2 is equal to what? Ln of e raised to 2 gamma. Okay. So this thing can be written as 2 gamma is equal to ln of 2, or 2.303 multiplied by log of 2. Okay. So 2 gamma, we can substitute for gamma here. Okay. So substituting for gamma, what do we get? 2.303 multiplied by 3 is equal to, gamma can be written as, okay, half of this thing. So half of 2.303 multiplied by log 2 multiplied by t. So this 2.303 gets cancelled. 2 can be taken on left hand side, so it is 6. Okay, so t is equal to 6 divided by log 2, and how much is log 2? It is 0.3010. Right. So what is, we can say round figure, it's 0.3 only. So 6 upon 0.3, 3 multiplied by 10 raised to minus 1. You can take that 10 raised to minus 1 in numerator, so it becomes 10 raised to plus 1. So 6 upon 3 is 2, 2 times 10, so it is 20. So t equals to 20 seconds. This is the answer. Option C. No, it's not option A. Option C is answer.